Use the integral test to decide if the following series converges or diverges. Remember, for integral test, we have three conditions. We first of all define an is this. Using an, we write fx just by replacing n by x because it's easier to work with functions than the series because n is more restricted. There are three conditions: continuous and positive and decreasing. Okay, this function is only starting from 2 onwards. So 2 onwards, log doesn't have any problem, so it is continuous, and log is positive. You remember the log graph is looks like this, and at 1 it is 0, but after 2 onwards it is always positive. So log is positive, n is anyways positive, so the whole thing is going to be positive also. So the second condition is true too. For the third condition, I can try to find f prime x. F prime x, this is kind of product of two functions, 1 by x times 1 by natural log of x. So what is the derivative of 1 by x? Negative 1 by x square times the second function plus 1 by x times the derivative of negative log x is negative 1 by natural log of x square times 1 by x. Basically, negative 1 by x square natural log of x minus 1 by x square natural log of x square. So negative out, everything inside here is positive. There is a negative sign outside, so this has to be negative for all x more than or equal to 2. So the third condition is satisfied too. So integral test says if the three conditions, these are the conditions which are we verified, then this series behaves similar to the integral from 2 to infinity 1 by x natural log of x dx. Now that's an integral, improper integral. So for improper integral, I need to replace that infinity by some alphabet, say b, and take limit b approaches to infinity of this integral. To solve that integral, I'll have to do some substitution. I'm going to say u is equal to natural log of x. That means du would be equal to 1 by x dx. 1 by x dx was already in the question. That actually gave me the clue. So that means when I have to integral 1 by x log x dx, that should look like 1 by log x is u, 1 by x dx becomes du. Okay, the integral of that is natural log of u plus c I have to write, but I'm not going to write that because my integral has limits. It's a definite integral. The u is basically log of x. So integral is this. So that means this can be written as limit b approaches to infinity. Integral is log of x from 2 to b. How do you put the limits? You put upper limit minus the lower limit. Log of b minus log of 2. Okay, now we need to decide what happens to the limit. When b approaches to infinity, log b approaches to infinity. So log of infinity also approach to infinity. Okay, so basically this integral is not coming to a finite number. It's a divergent. This integral diverges. Therefore, what are we going to conclude for our series? Therefore, the given series also, final answer, given series also diverges. Here we have another example, part C of question number 5. Integral test to decide if the following series converges or diverges. Remember, there were three conditions which we need to verify. The conditions were, let's figure out f of x first. An is tangent inverse n by 1 plus n squared. Therefore, f of x is tangent inverse x by 1 plus x squared. Okay. Conditions are function should be continuous, positive, and decreasing. Now, this all has to be checked on 1 onwards, right? Because the series is starting 1 onwards. So what I did is I drew the graph of this Desmos graph. You guys notice the graph is decreasing. It's staying above x-axis, so it's positive. After 2, I drew it. You can draw it before 1 at 1 also. So here you can say 1. So you guys notice the graph after 1 is a continuous decreasing graph and it's not breaking anywhere. Also, it is positive, right? So all those conditions are verified easily using the graph. Therefore, I can apply the integral test. What does integral test says? This series behaves similar to the following integral from 1 to infinity tangent inverse x by 1 plus x squared dx. This is an improper integral, so therefore I need to put a b in place of infinity and solve the integral, and at the end take the limits of b. To solve this integral, I would need to make some u substitution. U is equal to tangent inverse x. Du is 1 by 1 plus x squared dx. You guys notice that was already sitting there in the question. That is what gave me an idea of substitution. So my integral, which is tangent inverse x by 1 plus x squared dx, would be tangent inverse x is u. This part is du. The integral is u squared by 2. That is tangent inverse x whole squared by 2. I'm not writing any limits because I have the limits here, so I'm going to put it now. Limit b approaches to infinity. I've solved the integral tangent inverse x by whole square by 2 from 1 to b. Put the limits in there. Tangent inverse of b whole square by 2 plus minus, because we subtract, upper limit minus the lower limit, tangent inverse 1 whole square by 2. Okay. Now notice what's happening. When b approaches to infinity, tangent inverse b. Tangent inverse function as b approaches to infinity approaches to pi by 2, because tangent pi by 2 becomes infinity, right? So that is pi by 2 whole square by 2 minus tangent inverse 1 is pi by 4. So that is pi by 4 whole square by 2. Now I can evaluate that. It can be an expression number, but whatever this is, right? The most important thing, this is finite. Therefore, this integral converges. And we said because the series behaves similar to the integral, therefore we are going to answer given series also converges.